What's up? So a couple of weeks ago I posted some pictures on Instagram of this Harrier that I started building, and I thought I'd do a video about it. It just started because I was waiting for parts for a smaller airplane, and it was more to do with just could I make it work in Fusion rather than having any intention of building it. But there was so much interest that I thought we got to try and do this. So the plan is for this 3D printed Harrier. It's about 1 meter wingspan, and it was kind of pushed me to make it after people told me about this guy, Joel Vlasov, and his Harrier. And here you can see, it's a bit loud. And here you can see his 3D printed internals. And then he went on to fly that. You can see it here, it's flying really well. And then I think he built, there we go, you can see now, this glass fibre sort of plug that then the rest of it goes into. Now, I don't want to do that. I want to do 3D printed. And the other thing I don't want to do is, if you see here, he uses an EDF on the front and the back to help control the pitch and the hover. And I don't want to do that. So where I've ended up is with this sort of idea here. Let's just get rid of all the bodies to start with. There you are. That's what I started with. This is this sort of Pegasus idea. It's similar to Joel's I've subsequently seen. I've gone with using the air on the outside of the EDF for the forward vectors and on the inside for the rear vectors. And don't forget the middle here is blocked out by the motor. And then we take some bleed air off as well from the top for our reaction control systems. But what I didn't want to do is I didn't want to print all this ducting and print the vectors. Sorry, print the ducting. I wanted that to be integral to the body of the Harrier. So where I have ended up, let's bring all this back and then we'll break it down from there. So let's get rid of, hold on. That one, and that one. All right. So if we now break it down, I did this a minute ago. This is the second time I've recorded it, and it was so much slicker. Right, so here we go. We've got these red bits. They're going to be ducting, and this would be the roll duct with a valve here. And when the valve is closed, it diverts the air upwards. When the valve's open, the air can continue overboard. So that's how we're going to get roll. And there's obviously going to be one each side. And then for pitch, I kind of thought, wonder if we could do it just with a reaction valve in the tail, because it's the longest moment arm, and with this kind of dual-ended valve, let's go and show you, we can either supply air down, which is obviously preferable to give us a nose down pitch, or up, and servo. Oh man, like I said, I did this earlier and I was able to find everything straight away. There we go. So there's your valve that will move. As I said earlier, I wanted the ducting and all that to be integral, so these would be cut out of the solid body of the 3D printed aircraft, and the same goes for our kind of Pegasus motor. So I know where these bits are. So I broke it down into 3 levels at the moment. So if we get rid of the top and the middle, you can see the bottom level. These would be printed in parts. So so you've got one part here, that then it goes onto this part here. That might end up being split into 2 actually. No, it won't, it'll be okay, because we want to be able to print. Obviously you'll see that there's grooves in it for the thrust vectors to be able to turn in. Let's get back up here. And then the aft part, so they would go together, and that provides the ducting. So the EDF would sit here, and you then get the ducts. And then if we bring the middle back, you can see the middle. And the middle section completes the ducting for the aft vectors, and there's space for these. It also, when you put it in, it is what kind of holds the vectors in place, and they'll then turn. And I've cut out room for translating sleeves. On this top surface here is where the servos go. So we've got that'll be the KK2 board, 2 servos here to control the translating arms, 2 pitch servos here, 1 for the elevator, 1 for the RCS valve, and this will be the aileron RCS, and then we've got flaps and ailerons. I think that's the minimum number that I can realistically do it, space being the premium up here. Let's get rid of the servos for a second. So that was the middle layer, and then the top layer there completes the housing for the servos, and the top of this one. Now don't forget as well, there will be, is it that? Yeah, that'll be part of it as well, but it'll be built in, and so that provides the air for the front, goes around the outside, the back goes down the middle, and the bleeds will be bled off from up here, so these will extend in. And that's all off a 90mm fan. Now, there are so many issues we're going to have with this design, whether or not it's feasibly possible, I don't even know. But I'm going to learn loads, and it should be fun. So if you've got any comments, let me know what you think. Head over to the website, www.rc3dprint. There's a forum there as well if you want to get in touch.